I am Dan Hounsel, Senior Editor for the Facilities Market with Trade Press Media Group. Thank you for joining us for today's webcast, Cost-Effective Sustainable Solutions for Commercial Roofing Systems. Our presenter today is Paul Totten, who is Vice President for Building Enclosures with WSP. Here are today's webcast learning objectives. Gain insight into roofing systems and material advances that offer improved performance and longevity. Examine predictive and preventive strategies to extend the lifespan of commercial roofing systems. Review sustainable solutions, including advanced membranes, reflective coatings, green roofs, and insulation. And explore cost-effective options that balance cost with long-term performance. Attendees can ask questions throughout the webcast by using the Q&A button at the bottom of your screen. Type in your questions at any time, and our presenters will answer as many questions as time permits. At the conclusion of today's webcast, you'll receive a recording and PDF copy of today's presentation slides. You also will receive a link to a brief online assessment. Upon successful completion of the assessment, you will receive your CEU certificate. With that, I will turn it over to Paul.
Great, I'm sharing screens in a second, so hopefully everyone can now see that. Thank you for joining us. I'm going to discontinue my video so I'm not like overly distracting while I'm presenting. I'm going to cover a variety of roofing systems today. Just looking at roofing principles, the overview of low slope roofing and concepts, heat welded PVC and heat welded TPO, two of the more common single ply membranes in the marketplace. And then also hot applied waterproofing and the waterproofing principles that you would use below many vegetative roofs. All three of these systems actually can be used below green roofs, and we'll get into discussion as we go through each type of how they need to be applied. The general thing to remember is that roofing is roofing. You still need a 1/4 inch per foot slope on a roofing product, whereas a waterproofing system can be on a low slope or a dead flat slab without having that same requirement. So we think about roofing principles in its very basic format from, say, even a housing market. So it'll make sense in a second how we actually transition this to more commercial roofing. You're draining water along the slope of that roof. You're taking it down to ground, usually through downspout leaders and gutters, and you're draining it away from the building. You have a similar set of concepts that you apply when we go to low slope roofing, and now you're just tilting the roof inward, and typically your drainage is contained inward. Even in waterproofing systems, you're going to have this. You're draining it through plumbing in the building and taking it out of the building through a variety of either plumbing, sump pits, and other means. If we want to think about this in a slightly different format, we think about the principles of building science across our roofing system, and those are going to be very specific to the way that you want to think about design. You have to resist temperature, so we have insulation systems in our roofing system where it's warmer outside and cooler inside. One critical thing to think about this is in the process of thinking about re-roofing, you will have a chance to upgrade insulation. In the process of doing so, many times you have to examine your parapet height and your guard height, depending on where people or maintenance might be. You may need to add accessories to increase that height, but it is about the only time that you'll have a chance to easily do that on a roof that's not inverted, that's a single ply on the top. If you're in a waterproofing system, there's more opportunity to do that by removing hardscape, plantings, and literally upgrading the vegetation space below with more insulation. We have the same principle with vapor pressure, where your drive in most of the year is going to be from outside to inside when it's more humid, and like the summer and humid climates of the United States, and from the inside to outside during winter months or in humidified buildings. So if you have a natatorium, that might be a year-round drive where the drive is actually in the different opposite direction of this. We also have a cycling of pressure. Now, one of the things that's important with the cycling of pressure for mechanical is that's actually inducing a load on the underside of the membrane system, whereas if we don't have a temporary air and vapor barrier sometimes along the deck, or we have voids in the deck, you can get these weird pressure outputs on the membrane, and sometimes you'll find these around penetrations, you'll find things that are bubbled in a weird way, and that might actually be due to interior pressures. And then we have the wind pressure on the roof, typically on the top side that's pulling up on that gets combined with that. And so these two pressures are actually pushing and pulling on your roofing products. And then we have water, and of course water we want to drain and drain that along the surface of the plane of the roof. When you think about roofing, I want you to think of roofing systems in general as having the concepts of waterproofing, and only in a waterproofing system can we actually contain and hold water in volume above it. So if you have a pool, you've got a water feature you want to put up in your roof, that area would require waterproofing, and the rest of it could be roofing. But the same principles of water tightness apply. To maybe look at this a different way, we have elements that require absolute waterproofing, those that store, contain, or hold water. So if you have pools, a fountain feature, we see a lot of the amenity spaces on these roofs getting quite fancy from time to time. And so fountain features are actually starting to show up more on roofs than they used to just on plazas. You might have a cistern. We are going through this on a number of projects where you're looking for stormwater storage, possibly due to local code. You may see this in Washington, D.C., New York, but there's plenty of other cities in the United States now invoking stormwater storage requirements. And then you have planters in green and living roof space. These are all things that require waterproofing, where you have that more extensive, because you're now going to be storing water in those zones. There's a redundancy in the system that you need to recommend. So if we're looking at corners and we're looking at areas where we've got need for reinforcing, those are areas you want redundancy in the detailing, not relying on a single layer of material, because if you get a leak or an overflow at those areas, it's probably going to cause more problems for you. And then wherever you have a transition to another product, you need water tightness. So you may have a roof that say is 50% vegetated and the other 50% is a low slope roof. When we come up over that curb, we're going to need a tie-in between two different systems for dealing with, say, PVC waterproofing on one side and PVC roofing on the other side. It may be something that could be easily heat weldable, or we're dealing with, say, like a hot apply product, and then either a TPO or PVC that aren't directly compatible with the underlying rubberized asphalt. You need a separation layer while still maintaining water tightness. So those transitions are so very important. When we look at roofing, we can look at it from a different standpoint near the edge of the roof, especially a parapet condition, a coping cap condition. You're going to have elements that do still need to be waterproof. Those that shed in direct water, you need the roof to still have a waterproofing type concept. So redundancy in the seams, if it's the old EPDM systems, good lapping in the layers of a modified bitumen system or built-up roofing system. And then in PVC and TPO, they're heat welded systems, making sure we have those good heat welds. But now the redundancy, it's either self-adhered and heat weldable tapes, or PMMA liquid flashings over those seams to add that added redundancy. We want to think about skylights. Skylights in and of themselves can be tricky for water tightness, and so you want to make sure you've got good maintenance schedule for your skylights after they're installed, and then also good redundancy on the curbs and the tie-ins of that to not have issues with water. In addition, if you're in a climate zone that has more snow risk and snow and ice buildup risk, we've seen issues where the curb for the skylight might be too low, and that snow melt can find a way back through that rainwater would not normally do. So you want to make sure the height of your curbs, the way that you're maybe melting snow with heat melt, heat tape, which we've done on a number of projects where we can't get that height just due to limitations of the building, you're moving that water like you would on a normal roof when it's not snowing. And then again, the transitions are always key. Another thing that comes up, these are from GF, but there's several manufacturers, including Versico, that have tables. This one happens to be one of the more concise ones I found. As a facilities manager or an owner or somebody on this call, you can pull up the table. If you do a web search on chemical compatibility of roofs, you will find the two-page article that was really written from an owner's directive that they put out. What I find interesting about this is not every product is resistant to every type of thing you might have impacting your roof. So if you know you're putting a roof at an airport, there are certain roofing types that are not actually going to be friendly to jet fuel. And there's really only one major product in the marketplace today, and that's a modified PVC roofing membrane or a pure key membrane. I know the TPO manufacturers are looking at variations of this. What happens with the jet fuel is that the chemicals break down the chemicals in the roofing system, and the roofing system can fail. We find that, unfortunately, at airports, TPO doesn't get used because of this issue with the chemical compatibility. It's not against the membrane. It's a fantastic membrane on most other roofs, but this is something that we need to be aware of. If you're getting cooking coming up through, say, a stack, you've got grease, oils, vegetable fats, and animal fats, you'll find that you might have the same relationship, but now you see the TPOs are better performing than standard PVC, and only the modified roof, which is a slight upcharge, will find you that advantage of having that chemical compatibility. That's one you should always check on re-roofing, on repairs, and also on flashing materials. We found out recently that the PMMA flashings, the liquid flashings, are quite good with a lot of these products, but some of the other manufacturers' products don't always perform the same way because they have a different liquid flashing product. So just to give you a quick overview of the roofing technology. So heat welded PVC, we have seams between the roof that are secured. We're securing membrane here near a drain. but then we actually melt the plastic at this weld using a heat welder. And there's two different variations. In the field of the roof, not usually at the drain, but say somewhere over in the field of the roof, you're going to have a seam that you can run with a machine. The machine has to get to a certain temperature to make sure the welding of that seam is done properly. When we go to review roofs, we will take a probe tool with a rounded edge, and we'll run the rounded edge along here, not the pointy edge, because you'll poke holes through the roof, just to verify the seam's continuous. And the manufacturer will do test cuts. Usually, if you have a roof going down, even on replacement, you can require the manufacturer, ask the manufacturer to come out during the installation. Most of them are very willing to do so. They will do test cuts to check the welds on a heat welder roof and verify you're getting good weld quality. Just because the weld looks good doesn't always mean it's continuous. And even sometimes when you probe the edge, if they didn't get the right temperature, this might not be a good continuous weld. When they do that test cut and they do the pull test, they will verify it doesn't meet requirements and give better guidance to the installer, sometimes due to outdoor temperature just not being warm enough. Still warm enough to put the products down, but not necessarily warm enough for the heat welding machine. The second thing with those is that you have to look at where you might need reinforcing, and we'll get to that in a few slides. You have areas of the roof where you're going to require reinforcing of additional membrane on top of this so it doesn't stress the key weld, the base weld. Another thing to note is you can use it below a green roof if it's waterproofing, or with redundant seams and slope. So you'll see this with vegetative roof trays. You can use a green roof. You need to maintain the roof slope at 1/4 inch per foot, which means you're going to have a sloped roof everywhere. And then you're going to actually have to put the trays on something to balance them out if you want that nice straight look of the green roof. You're not getting the waviness of the sloping and the cricketing of the roof. The other thing to note is that you're actually going to recover. So if this was a seam in a vegetative roof system with the trays above, we'd actually have another strip of membrane over top, over to here, that would either be welded on both sides or the adhered and welded system that the manufacturers sometimes use. I would not use, and they're not allowing for use, the PMMA liquid flashings over this because of the risk of roots breaking down that product. So it's an added cost, it's an added redundancy. And if you're familiar or have been around the old EPDM roofs, when you got their platinum roof from any manufacturer, it always required that redundant seam tape for the same reason. They've taken that same technology now to using heat welded in a green roof. If you don't have the space to get the slope, you then switch it out to a waterproofing product. The thing to know about PVC waterproofing, regardless of the manufacturer, is it's not UV stable. It doesn't have the stabilizers they put in their roofing product. And in doing so, that lack of UV stability actually creates an issue for it being exposed. So you can transition from the waterproofing, when you say come to a vertical wall, with a section of roofing that's married into that with the redundant seam tape. And that can be quite effective. When we look at this, we've used it in some very unique applications. This absolutely happens to be a gutter below a skylight system that's not yet installed. Unfortunately, on this project, the ship had sailed and we were tasked with a gutter that was actually sloped inward and draining 6 stories of facade through it. And so we created this strange shaped gutter to use hydrology to flow the water in a way that it didn't actually create issues. The great thing with PVC is that you can also buy PVC metal. What you're not seeing is below this gutter is actually PVC metal, and we welded seam technology over every seam in the metal and then brought a liner inside of it. So you can use these products to actually create waterproofing redundancy within the product in unique applications, and they end up being very good for that. This particular one has been performing now well over 11 years without a single issue with the product because of the way we built that redundancy in. And then again, looking at the seaming technology of adding additional redundancy at the seams, one of the big risks is that you might get overmelt. So you see the X, this was marked by the installer. We went and patched this corner. And in something like this unique gutter condition, there's more risk of that. This is actually a fairly clean welding system. You're going to see some bleed out on those welds that are field welded, and they're still good to check and probe. You have 3 ways of putting these down. Fully adhered, which means it's set in adhesives and glues. The adhesives have gotten so much stronger. We find that we'll find a segment of the market that used to be mostly mechanically attached, and now they're actually stronger with a lot of the adhesives. A good roof build-up is, if you have a concrete deck, you're going to build it up from the deck, put in the self-adhered vapor air and barrier, the redundant roofing system, the temporary roof. Even on a re-roofing project, it makes it easier to do the tie-in between the existing roof and the new roof product that you're putting down. It makes it easier to keep the roof watertight during that re-roofing project. And then above that, you'd have your layers of insulation. You want the seams offset so you don't have a airflow path through them. Also keeps it better for weighing them down while you're getting wind on the roof. A cover board is highly recommended, of 5/8. Sometimes you can go thicker if the manufacturer makes it. And that also in areas of the country, we have a lot of risk for hail, whether it's winter's time or like Texas, sometimes before you get major storms, you get hail. It's good to put that cover board in, and sometimes you'll add flexible material in hail areas that the insurance companies. The second is mechanically attached. And this is actually putting screws all the way through the system. Your heat welds over that will provide covers over the screw lines. And then the last one is using a proprietary system that's available to every roofing manufacturer, that's sold by one roofing company, but it's the Rhino Bond system, whether you're induction welding. One thing to note is in some of the high wind areas, mechanically attached tools usually still work. We're finding that the Rhino Bond doesn't quite get to the highest wind loads, just because of the way it's melting the bottom of the roofing system through induction welding to the fastener. And there we usually end up with a combination of fully adhered and mechanically attached and that. These are the three predominant on the marketplace, all acceptable to the roofing manufacturer. You really want to work with your design team and your enclosure consultant to determine what is best for your product and your project. If you have FM Global insurance or FM Global requirements that you follow, if you're not insured by them, you'll find that all three of these end up in FM systems. So that's a good thing just to note. Heat welded TPO is very similar. It's a different plastic makeup. It's a different variation of the plastic, and it's not the same as PVC. The products have improved over the years. In the early days of TPO, which followed the PVC market, there were some issues with things like the chemical compatibility, just the way the welds were working, but they have worked through those many years ago. We're finding great success with TPO. It tends to be a little bit less expensive than PVC most of the time, but we are finding with supply chain issues that happened during COVID and sometimes continue to happen, price both. Sometimes you'll find that you might find that a product you expected to be more expensive is actually less expensive. The other thing to check for any roofing product, the familiarity of your roofing trade with using the product. So you're doing pre-qualification. One thing you can do, whether your design team, your enclosure consultant hasn't already done this, or you can ask them to do it, call the manufacturer, find the local rep, ask them who their best 8 or 10 regional people are for putting their product down. Every manufacturer will be happy to recommend people that are very qualified. And if you corner them on a phone call, if the enclosure consultants get this more, they'll even sometimes tell you who you should never use. And they're looking at unqualifying from their listing. We find that most of the time we get a good list in almost every major city and even in some of the regions outside of a city of at least 3 to 5 minimum installers, and many times the list is over 10. There's more requirements now for more training between years for these manufacturer certified installers to be retrained on any new products, any new materials, any new systems that have come out. And we're finding that that has made a huge impact on improving the roofing industry as a whole. Similar to heat welded to the PVC, it can be used as a green roof, but with redundant seams and slope. This cannot be used as waterproofing, and that's a big difference between the two products. You would still follow the same thing where this would be trays, not the extensive roofing. It would still be sloped a 1/4 inch per foot, similar to a standard low slope roof. You're still running the redundant seam tape. I would like to note that the TPO market was the first to do this before the PVC market got into it using the standard roofing. It can be welded to some expansion glands, and all these roofs, when you get a fusible expansion gland and be able to weld to it and tie the two systems together using that welding technology, it's a much more durable roof. And then on both PVC and TPO, you can use TPO coated metals for like your gravel stops, some of your coping tie-ins, and that allows you to weld the membrane directly to that product. If we look at a buildup of any of these roofs, whether it's TPO or PVC, and this is a TPO example, you've got your tapered insulation, and that's all this stuff and the segmenting of that. You've got your cover board that's going down on top of that, and here you can see it's being secured with mechanical plates through the system. This is signs of adhesive below the system. And then on this particular project, we took this off of, so this was a 60 mil reinforced TPO. They have a variety of thicknesses. The thicker the product, the more durable it is. The thicker the product, the more careful the heat welds have to be because you have to melt more of the plastic. As we look through any of these roofs, TPO or PVC, there are certain things in the detailing we want to see. Many times they'll have these preformed accessories for going around penetrations, and this is actually a preformed molded penetration accessory. When you have the ability to buy these rather than field making them, they create a more durable roofing system. We have a preference for circular columns versus rectangular ones. are ones with at least a rounded edge, which this one has. And the reason is for the ability to better and easier roof the product. When you have a corner that's sharper, it's harder to make these accessories work. So most of the time, we're now finding a lot of the roofing suppliers for dunnage and other systems coming up will either provide round or they'll provide rounded corners at least. When you get to this, you're going to be looking for covers. So you see all these little circles here. They're hard to probably see. We circled one here purposely. These are called T-joint covers. Whenever we bring a weld across the system that's making a T, we're adding this reinforcing so that weld doesn't pull apart. Without these, you'll end up with localized failure of the roof much sooner than expected, usually within a 5 to 10 year period. Absolutely critical in the detailing. When we get to scuppers, scuppers can be done in TPO and PVC. One thing to note with these and doing the scuppers is that you want to look at the manufacturer's detail. Usually offer multiple layers of redundancy through these. You also want to look at the height. This is one that was meant as an overflow. The roofing was in a really weird spot. This is actually at a high point, so it's a little bit deceiving, but you can sort of see the slope off this side. So even though it looks really close to the roof, it's actually at the high point for the scupper. So we made it work that way. As we get these in, you'll see this redundant like sealant around the edge. This is actually a secondary piece on top of the primary heat welding. So it's a redundancy on a redundancy, which is really good to have. One thing to look out for with these on re-roofing and also on initial installation of a new roof is where we have these corners. A lot of times we'll have the same T-joint patches put over these after. It's inevitable that you'll find these little pinholes because they have to cut the membrane to make the shape around this. You also will have some risk of overmelt. This amount of overmelt that we're seeing here is not too bad. This little thing that's here is part of that overmelt. So you end up probing the seams. You'll have the manufacturer rep come out and check those more often. It's really critical that these areas are monitored, but this little pinhole will result in a lot of water infiltration if it's not patched over. You can imagine everything coming off the redundancy in the curb, coming down, and what it does is it follows the coursing of the edge of the seam, and this ends up being a little gutter and downspout system into your building. That's one thing to look out for. We are doing pre-warranty closeout walkthroughs. So you're gonna end up with 2 warranties on most roofing projects, unless you get a single one from the manufacturer that's covering both labor and materials. You'll get a manufacturing warranty, which will cover their materials for the actual products. It's not covering your installation. So you get a 25, 30-year warranty. It's for the material breakdown. If you get combined labor and material warranty, you might get one that has a 15-year period covered by the manufacturer. They're coming out more often to observe the roof, verify it's been down properly, and meets all of their requirements. If you're doing a warranty walkthrough, many times you get a 1-year warranty. I would always push for 2, and our preference is asking for 5. Pay for the upcharge, and what you'd want to do is within the first year after, walk the roof and look for little things like this, especially if you're having issues. Get them repaired while they're still under warranty. Don't wait until the warranty is done. I think that what you'll find is that it makes it easy for these little things to be corrected. Here's an area where we have a pinhole actually in another corner. This is an outside corner. And this was actually formed by overmelt. Here our solution was actually to weld a new patch over this entire zone, to get away from the overmelt areas. And again, it was a mechanical curb, which is a bad spot to have it. And this is one where the mechanical equipment is set more inboard. And on the next slide, I'll show you what that piece of equipment would look like. And this is like the curb that's outboard of that. And so here's kind of that type of curb type that I was talking about. Here they were trying to use sealant to patch over overmelt areas. We can't rely on just sealant. Even with the PMMA liquid flashing, it's not our preference to accept that. We really want this membrane flashed over first. And then if we want to put a redundant liquid flashing over the corners, that's perfectly acceptable. What we find is just relying on sealant. The sealant will break down sometimes within a 2 or 3 year period. And now where all those deficiencies are, you're going to have water infiltration. You're actually going to have leakage. Here's another view of some of the dunnage and some of the shapes. This one hasn't gone through the secondary, so this photo was taken when the base flashing was done, and we hadn't yet completed the top of flashing. What you'll notice here is that this is gapped around the edge, and so what ends up happening is this gets a redundant boot over top that then flashes over. When we do this in PMMA, one thing we want to be careful with the liquid flashing is when we carry this over, that this is taut, and so we still prefer having worm gear clamps around these to pull them tight to make that flashing more successful. Here's a good one of showing that in progress work, where they've got some temporary tie-ins, some temporary sealant work around the post to keep it watertight. And just a lot of, you can imagine, careful hand welding by the installer. They've got to take time with doing it. If you're rushing somebody to get off your roof, one thing you might end up with is a lot of unintentional deficiencies because you haven't given the installer sufficient time to actually do the work. And so one of the most cost-effective things is not letting them have an extended schedule because they're just taking their time, but making sure when you discuss schedule, ask them if there's going to be areas where the penetration detailing is going to take longer or the drain detailing is going to take longer. So you know that, especially if you're on a phased roof project. You may be somebody who's a facilities manager for, say, a hospital. You may have a helipad, and that downtime is actually critical to get progressed. Get those walkthroughs with the installer, roofing manufacturer's rep, the enclosure consultant, the architect, done efficiently. Mark out everything, get them repaired, so you can get that helipad back up and running. Here's another example, somebody overdoing it with the sealant on the top of the boot. We were able to look at this when we did the phasing. We determined that the actual detailing below was done correctly, and this was somebody who used a little bit too much sealant on this detail. It actually wasn't problematic in the end. We know this is a self-adhered piece because we can see the adhesive creeping out at the bottom. And what you see on the other one nearby, the sealant is not as voluminous. Here's another location. We have a fastener on the deck. Fasteners from trades that come after or from the roofer themselves. It's very easy for somebody to step on a fastener and put it through the roofing system. And so we want to just be careful about the fasteners that are on the roof, that those get picked up. What you're seeing here is also marking of areas where we've got deficiencies just about to get underway. We checked these curbs. We found some areas where we had some correction on this roof, and they were able to do it in sufficient time. So that's something just to be aware of. So I'm going to switch over to waterproofing. Hopefully that was enough information on roofing. I'm sure there's going to be some questions at the end, and we'll get to those once we get through the waterproofing section. When we look at waterproofing, there are two types. I'm only going to cover one of the two types today. PVC waterproofing uses similar technology to PVC roofing with heat welded seams. It can be adhered, it can be glued down, it can be loose laid. You have to ballast over it. And then they have self-adhered versions, and there's multiple manufacturers to make that. Hot applied rubberized asphalt is a different animal. It's not the only other waterproofing in the market. We also have fluid applies like PMMA made by several manufacturers. In certain cities, we find there's a ban on hot rubber. And the reason is we have to take this kettle to heat it up. A lot of times you're torching the membrane and it creates fire risk. So for example, New York City, we're not allowed to put this up on a building without fire marshal approval, which there were a certain number of stories. And the fire marshal in New York never approves it. So we've seen a huge change in what materials are being used in New York for these systems when they're done at height to reduce the fire risk. It's redundant based on the layering of the system. It has a reinforcing layer. This is very critical with any fluid applied waterproofing. So whether I'm using a PMMA type waterproofing, again by multiple manufacturers, which is a cold fluid applied product, usually comes in white, can also come in tan. They all are based on the reinforcing thought process of a hot rubberized system. So this reinforcing layer is absolutely critical. And the other thing is it eliminates seams because it ends up being monolithic. And this is true whether it's a cold applied system or the hot applied system through using this product. Another thing that's very key for any waterproofing, not just hot applied rubberized asphalt, you want to understand the moisture leaving your deck. And the reason for this is the moisture leaving the deck, if it gets drawn through something you're putting down at a very high temperature, what it's going to do is actually create pinholing in your waterproofing. Even on a cold fluid applied product, if the deck is too wet and I put it down and the sun hits the deck, it can heat the moisture in that deck and drive it through the waterproofing where it pinholes over and over again. So that's something just to be aware of in the process of doing this. Another one we do sometimes for decks, again, we would not do this on a post-tension deck because you have the risk of hitting a cable, but we will run interstitial concrete moisture tests sometimes if we're getting the mat test to fail too often. What you're seeing here is sort of the moisture that's building up below the mat. So we end up running a bunch of these similar spacing, and we're then able to see an interstitial RH, which we can then run through software to calculate how long is it going to take for this deck to be able to dry to allow us successfully to put down the hot applied system. In a cold applied system, the answer will be sooner because we're not heating it to the same temperature. To get to the idea of temperature, you heat the kettle and the material to 400 degrees. What you're putting down the deck, we usually will range between 385 and 390. They usually will carry a thermometer in the bucket that they're using to pour it. You're literally pouring 400 degree temperature material onto your deck. And now it probably makes sense that that moisture has a tendency to migrate upwards and can create other problems for your system. When we look at the layering in the system, this is a great image to show the layering. So this is looking at install from bare concrete towards you. So what you're seeing is the bare concrete of the deck. We're seeing the aspects of the primer, which is why you're seeing stuff that looks like it's going through. We're seeing the base layer finally going down. So they've poured that out of these buckets onto the deck. And what they're using is a squeegee to literally push this rubberized asphalt product out. This white product is the reinforcing layer. What you can see here is it's being pushed through with a broom. Once this is down and applied to the right thickness, between the layers of the hot asphalt to put that down. And then what we're seeing is the top coat down on this portion of the screen going on top of that, and eventually set into that as the protection course. So the protection course will have seams, but what you will see eventually is that the actual rubberized asphalt ends up being monolithic. One thing that we need to monitor is the seams and anything that has a cover board. This is our roofing and waterproofing system below. We're seeing bleed out here, but we have to make sure no debris gets stuck below this. If we get like stones or fasteners stuck below it and somebody steps on it, it can actually puncture the waterproofing. Many times we find these little localized leaks are tied to a screw or a piece of rubble getting stuck in the system and ending up below the waterproofing layer. That's just something to be aware of. If you're up as a facilities manager watching the roofing come down, make sure if you see it, tell them about it, have them monitor it. Your enclosure consultant or your designer, if you're just hiring a designer, can do the same. It's another reason to bring out the product rep and the tech rep in your region a few times during the job to review it as well. They will also call out these deficiencies that can be created by trapped debris. We will sometimes transition to another product to do the penetrations. One of the examples is uncured neoprene. Another one is a modified bitumen. If you're familiar with built-up roofing systems, which is usually several plies of built-up roofing are made out of an asphaltic sheet product, you can do these penetrations. We find the uncured neoprene is a little more flexible to do them, but there's no reason you can't use the stiffer modified bitumen product. What you want to see is a good zone of application of it into the hot applied. So what we're seeing here is actually cut back in the protection course to allow them to detail this penetration. So what you're seeing here is the edge of that protection course. This is the actual waterproofing below. And what we're seeing in this area is actually a deficiency they had to correct. That's actually the deck. I can see a little bit of concrete. We had them go over that one more time. And they were laying the sheet of neoprene in. The other thing they hadn't moving in on all four sides. This has to be melted between two of the layers of the hot applied waterproofing to create redundancy so that water doesn't get under the seam of the sheet. The sheet eventually will get turned up on this. So what we're seeing now is just the primer. They'll wrap this whole thing with the same product. It'll get married into a circle at the bottom. And that is your waterproofing. Again, the top of it will get a worm gear clamp. And we usually like doing what's called a witch's hat, which is a flashing that comes in, down. Sorry, I'll go back to that. It comes in, down, vertical, and kicks out and looks like a little witch's hat. You'd run the redundant sealant. It also gets a worm gear clamp around it. That way, any water coming down the penetration is likely to get outside of this. Any snow buildup again, that flashing actually helps melt it because it's metal. So it ends up having more redundancy than people expect. Here's another view as we get to the edge of the roof. We have a requirement for corner reinforcing the system. So what you're seeing here is actually our 6-inch wide uncured neoprene being used as a reinforcing layer. And what you're seeing is the reinforcing for the system goes on top of that, and we're marrying this in and sandwiching this in into a nice waterproofing sandwich. Not one that's edible, but definitely one that will keep stuff out of your roof. We have our upturn happening, and so what will end up happening over top of this is your layering. These boot prints are an issue. This is the workers walking over the system. This will all get encapsulated. The intent is to have this embedded in the system, so there's no issue in them doing that. So this is what happens when we have too much moisture in the deck. When we put a hot applied system down, we will get percolation of the moisture. So what happens is you heat up the deck, and as you heat up that deck, that moisture will migrate upwards and create these pinholes. When you see pinholing, you need to come back and hot mop a new system over it. When it's this degree of pinholing, it's not too bad. Hot mopping is enough. But we see too much, we also may see it re-emulsifying, which requires them to scrape, remove it, and start over. And that you'll see that in a couple slides what that looks like. Here's a hot rubberized area that's free of pinholing. And so again, on the same roof system, we had an area that had too much moisture, one that didn't. And this was good, and there's no blistering. So we have this consistent look. It's very nice to see that, and that's what we want to see on this type of roof. This is where we see inconsistency. And actually what we're seeing here is not only inconsistency, but just a little bit of re-emulsifying in the buildup. We don't want this thickness to be inconsistent. We end up with this less waterproofing in some zones and more waterproofing in others. And you don't have the proper system down. It's not really warrantable, which is a different problem for you if you have a warranty claim. But at the same point, it's not the consistency we're looking for. Here, they were just starting to get their neoprene down. We caught this early. All of this got taken out. They were able to heat and scrape this away, get back to a good consistent base layer with new base, and reinstall the waterproofing. Here we have an area of protection courses damaged. We had them verify the waterproofing underneath wasn't. We had them reset new waterproofing. Part of this was wear and tear of equipment moving across the deck. If you have a new system going down or a replacement system, you want them to put insulation and plywood down anywhere they're moving equipment around. And also make sure you're putting weights on that so it doesn't blow off in the wind. Here's an area where you can see a scissor lift was parked too close to it. It's actually damaged the waterproofing at the edge of this area where they were using the scissor lift. And so we actually had to have them come back and re-waterproof. Those adjacent construction activities are very critical for coordination of a general contractor. Of course, if you're doing a re-roofing or re-waterproofing project, typically you're retaining that subtrade directly, that specialist in roofing projects, and they're going to come through and do that work. But you may also be adding new cladding for a dress up for a rooftop amenity. So this is not uncommon to have in both new design, but also on re-roofing projects, something to look out for. Something as an owner, you want to make sure you're covering in the contract drawings you're delivering and the specifications you're delivering from your designer, whether it's an enclosure specialist on a re-roofing project, or it's an architect and enclosure specialist on the initial one. Absolutely critical that they have that covered. Here's an area where this is UV exposed. So the actual hot applied asphalt, it's similar to PVC roofing, waterproofing, sorry, is not UV stable. The cold fluid applieds are, most of them are. I would say that there might be one in the marketplace that's not, but I think they're in the process of making it UV stable. But for the most part, the PMMA ones are UV stable. So when you leave the product exposed too much and you haven't covered it, you'll get this cracking, and that's due to the UV breakdown. You come back and you re-waterproof it, you're resetting it. You're making sure this was an area where we had an upturned curb, where the flashing in the equipment was delayed. And when they went to get that done, we had them reapply this and then let that cure, come in with the new equipment flashing. So no issue in doing that. So that covers the general aspects of the roofing and waterproofing. What I'm now going to cover for the next little bit is a little bit on vegetative roofs and just the layering of stuff that goes above these to make the vegetative roof work. So whenever we're looking at a vegetated or vegetative roof, we have a variety of things that you have on top. You're building up the insulation, you're building up filter fabrics and stuff on top of your waterproofing system. And sometimes similar, you're building up maybe a filter fabric or an additional drainage board on top of your low slope roofing at 1/4 inch per foot. The big thing to remember is you got plants and sedums, you have hardscape, and for both of these, you have wind lift. The higher you get up on the building, the more risk you have for wind tear off of the product. And you can reinforce these with a fastener system in the field. There are ways of, some of the manufacturers have really cool disc systems to hold down plantings, coupled with like a little cable system. So when you're designing these, one thing you want your designer to do or ask them that they've done, engage the manufacturer. You would go to usually the national technical reps. You'd call their 1-800 number, usually get aligned with somebody on their national team who's been with the roofing manufacturer for many, many years. Usually their top-notch detailing team that draws all their details. And they'll ask you to send details and no cost to you as an owner and no cost to us as a design consultant or designer when we're stamping the sets. They will provide markups and information back to you to make sure your warranty is assured. And you can understand the criticalness of doing that in any project, whether it's re-roofing or it's a new design project. So we have our base waterproofing membrane or roof system. We have our stuff we're going to put on top of it, our plan, our CDM, our hardscape. Where you're going to put the roof barrier is going to be critical, and then our wind uplift consideration. So all these are going to be absolutely critical to work through. And again, making sure you've had communication with the manufacturer. When you look at a vegetative roof, when you get your sedums, this is what it looks like. You got all your soil below this. You may have trays. This happens to be a tray system. You have this fabric for all this to take hold. But when everything shows up on day one, it looks like this. Don't be surprised if you got burlap sitting on your roof that just looks weird for a while until the plants take. Another way to look at these is looking at the buildup. So here's our, happens to be a hot applied system. This blue product is the root barrier. What this is doing is avoiding roots that may migrate down through the system because again, our roof, even on a tray system, is all above the membrane. You don't want those roots growing into your waterproofing and creating voids. So we put the root barrier in as a redundancy, and in this particular manufacturer's process, it's directly applied to the top of the waterproofing system. We then have our insulation. You can see some of the offsets happening on our vertical and our horizontal. We're now laying out our root barrier to extend across the entire roof and our drainage board. And what's going to happen is that we're having overlaps of a lot of our products. We like the 2-inch. Some manufacturers will state more. That's good for the design team and the contracting team to know that. If they require 6-inch overlap and you don't do it, it actually creates warranty issues because you now haven't installed it per the requirements. And so you want to make sure that those overlaps are happening. This is what a green roof looks like as we're moving soil around. It looks messy. It's very messy. These are messy to walk. And I think what you're going to find is that you've got a lot of transitions that you've got to worry about in the filter fabric. It looks like we have quite 4 questions in, and we'll get to all those at the end. So we'll work through this, but that's good to see come in. We have our soil. And what you see is very much gardening equipment, rakes and stuff. You can understand why there's importance of getting everything kind of built up, your insulation, everything below, to really protect that waterproofing. This is the same roof I showed on the previous slide, and we're moving that around. You can see why that parapet was so high. I'm going to go back for a second to the previous slide. This parapet looks really odd, doesn't it, at the height? But now when we look at it, to get to the sufficient guard height, you're like, wow, all that buildup, right, of soil. This one happens to be 4-inch. On extensive roofs, we might have 8 inches, 12 inches of soil. I've seen some deeper around the planting boxes with trees. So you really need to make sure this edge condition, if you're going to do large trees, you don't put them near the edge. You put them in the center of the roof so your edge condition can be maintainable at this height. When we get to our drains, additional considerations for the drain interface. We usually will have a drain box cover, some river rock or ballast. In high wind, this may actually have to be higher stone, so the wind doesn't pick up the stone and maybe impact a curtain wall and a rising wall. Here's that burlap with the sedums and our soil. What also happens is that we'll typically have a filter fabric turn up. So when you're looking through this, you'll see these really dark look of this, not like this where you can see a little bit of what looks like daylight. What this is the filter fabric outside turning up to avoid soil washout. Only water is getting into the zone. That's critical to not foul the drain. I like this particular roof because we have a redundancy where we have almost like another sieve to reduce some of that coming through. A lot of dirt will get retained in the ballast. Here's a foul drainage board on another roof. This was one we were investigating. And so this is one where the top geotextile had gotten pulled back and nobody noticed, and they continued to put their soil down. And so they fouled the drainage board. If the drainage board gets fouled, you're not actually going to be able to move water through it, and that's going to create issues for the roof over time that we just want to be careful about. So this is a big one to walk. If you've had a roof and you're opening up something for, say, a repair, always make sure they double check the drainage board where they had to modify it and that they've got the filter fabric properly done. When we get to hardscape, again, on a similar roof on a similar project, these things get built up quite high, and to align with the top of plantings, you might be on some very high pedestals. This is one on a lower roof on a building that was only a couple stories high. That gives you a sense of the buildup. Here's our waterproofing. They would be the same below the vegetative areas. Here's our insulation being built up from a variety of manufacturers. So disregard the color of the board. You can get them in blue in about 18 different variations depending on who you're buying. But this would be an extruded polystyrene product that's more rigid to take the load of these pedestals. Here's a pedestal system with tabs to align the pavers. On a high wind system, you may find that the corners of these pavers are carved out. They actually have an anchor that gets anchored to the pedestal for weight, and that's going to actually make the system act as one system. We see this below helipads. We see this in buildings on high rises and skyscrapers as a more viable system. We'll see this in areas of the country like Florida, Georgia, parts of Texas in the south where hurricane loading is much more critical, up the Carolinas, right, in the same sort of thought process. You want to make sure you're buying the right pedestal system. And there's at least now 3 manufacturers that have a good interlock system in the market. So you definitely can meet your minimum 3 on process of doing this. Another way to look at this is maybe an up-close view, and that's looking at the tab system. These are plastic tabs. This happens to be a shimming piece on top of that are easy to break if they're not applying these properly. And what they're trying to do is create this gap for expansion joint between. You can get ones with metallic tabs now, which are more durable. If you have the option of doing that, pay for the upcharge. The plastic tabs are still reasonably durable, but after resetting these a few times for maintenance, if you have a drain down below you have to get to, you're going to find that they're going to get broken. It's going to be hard to keep the pavers in place. The good news is some of the pedestal manufacturers, this one you can see is a screw jack that allows them to kind of jack it over a PVC pipe, but also a lot of them have now where you can pull these up and actually drop a new tab system in. So there's 2 ways of looking at this. The new tab system is rather inexpensive to buy. The metal tab might be a 1.5 to 2 times upcharge, depending on what system you're going to. You could decide as a facilities manager, I can just stockpile these and replace them on the fly. That's also a good process, but something to think about. So just as we conclude the considerations for the roof, and we're almost at the end of the slide presentation, we can get into questions. A summary of these. We have details and interfaces and terminations. They're going to need close examination. That's going to be absolutely critical to do. What I would say is if you're requiring from an owner standpoint, a facilities manager standpoint, requirements for re-roofing, make it a requirement that your design team has to show the details for every critical interface, not just the common ones, but everyone on your roof that's atypical. We work with facilities managers that say are at hospitals, science and tech, data centers. If I've missed you in this mix, I am not intending to. Museums, schools, we find K through 12 and universities where they're requiring that durability more often. We find it with a lot of our commercial market clients as well. Require this of them, and then have a peer review internally. You may even hire a second consultant to do that peer review. It's going to be absolutely critical to spend that money on the design. And then during the construction, you're going to want to have somebody observing that. You could have a registered roof observer, which is a certification, or a registered roof consultant in the industry. At a minimum, verify the years of qualification. I would recommend that whoever is observing your roof, if they're coming out and they have a senior person looking at it, at least 10 to 12 years of experience observing roofs. That aligns with the RRO, the Registered Roof Observer designation. I would say 15 to 20 years experience for the person who's more experienced coming out, and that would align with the more senior certification for registered roof consultant. And make sure that their experience is just not in general enclosures, but has a lot detailing with roofing. Ask for those qualifications. The same with your roofing supplier. Ask the manufacturer who's really good at detailing as well, the rep. Key elements to require periodic maintenance get verified. Here's a huge tidbit for every facilities manager, everyone on the call today. You can request from every manufacturer that makes a roofing product in this country. I've checked almost every one of them in the last 6 months for different projects. A systems manual, a maintenance manual for your roof of how often you need to maintain everything on your project. You can make that a requirement for the specification of your project through your design professionals to require that as a submittal at the front of the job so you can start planning for how you program that in. Absolutely important. And then this gets to the last one, the information on the means, methods, and the rate of maintenance required. There's some key walkthroughs I would recommend you have. Walk your roof at least every 2 years, every time you get a mechanical contractor if they're doing work. I would walk it 6 months before any warranty expires with the warranty holder, so there's no argument in stuff needing to be repaired. And with that, I will conclude my slide deck with my contact information, and we're ready for questions. And just quickly, thank you to our sponsor, Versico, for sponsoring. We'll come back to that later, but at the same time, we'll get into questions now. So Dan, do you want to kind of feed those over and then I'll go through? I'll reshare video so that everyone can
Absolutely,
see
I can
me.
handle it. Good information, Paul. Very good information. Just a reminder to attendees, you can, in fact, submit questions by using the Q&A panel at the bottom of your screen. Just simply type in your questions and we will answer as many as time allows. We have a couple of questions here, Paul, from a gentleman regarding EPDM roofs. These are from Ron Orlando. Ron, thank you for your questions.
Okay.
The first question has to do with he's not sure exactly when his roof system was installed. Is there a typical lifespan
Sure.
for an EPDM roof?
Yeah, EPDM rubber roofs are still a really good roofing product. We still put those down on projects. They don't have the same redundancy. So you will find that if you don't have the redundant seam tape, your lower end of it, that would be a 20 to 25 year span. You can get 30, 35 year roofs still warranted for those. So if you're unsure of that, one thing is you can look at the quality of the rubber. If it still has most of that, if it's a black EPDM, because they do make a white version, it's a little hard to see this. But you get up and it's starting to look a little bit more gray. It might tell you it's about 7 to 8 years old, if that helps you. And then if it's really gray, it will give you a sense that's probably close to that 10-year mark, depending on where you are in the country. And so that's something to just look at. You want to look at the seams and review the seams. If you see redundant seam tape, in other words, stripping in, and it doesn't look like it was done during a past repair program, it usually means you got a higher end roof. Your redundant seam tape warranties were the ones that usually run 30 to 35, and sometimes even longer from some of the manufacturers. Your typical warranty for that, the 10 to 15 years is a good thought process, but most of them are longer than that, even on a good rubber roof that's installed today. And so again, if you have that sense that you're in that 7 to 8 year frame, you might anticipate that you've got another 7 to 8 years before you want to think about re-roofing. And then you can think about that process of that re-roofing project going back with the same project. We have campuses that maybe that was their go-to roof. And so sometimes we're being required to put the same roof down because sometimes their facilities people have been trained by the manufacturer. We've had that in a few of these campuses to do the roof repairs. We also have other buildings of a similar nature where they're upgrading to maybe a heat welded system, but it doesn't mean that EPDM still isn't a viable product in the marketplace. So hopefully, Ron, those answered your questions.
Okay. Question on a couple different things here, but a question on flashing specifically. Marty Jakovics is asking, how are new TPO and PVC systems prepped for a PMMA liquid applied flashing?
That's a really good question for Marty. So there's a variety of ways that those get prepped, but usually you've got some sort of primer or cleaner that's put down the surface to get that membrane back to clean, especially on like if I'm doing a repair. The big thing with the PMMAs is making sure that your installer is very familiar with them and the thickness. If I can still sort of see through them, they're not thick enough. There is a coating that's required, a coating thickness you're supposed to check. You want to come in and make sure that you've got the right surface temperature. You're not installing them when it's too cold or not the right temperature for both air and surface. You'll have problems with the PMMA sticking. And that's layering in that base layer properly, coming in with the reinforcing layer properly, and marrying that in. There's some great videos out there from almost every major manufacturer on how to put these in. You'll find them on YouTube. You'll find them if you search the manufacturer. I recommend that each of you, if you have a chance, go look at them. They're fun. I think there's actually somebody who recorded from a roofing manufacturer, not from a manufacturer, from an installer, things to do and things not to do. They actually recorded some of their own deficiency issues that they found in learning how to do it. So you will find those educational videos. Just don't take everything with a grain of salt, because some of it might not be all good information, but usually most of the time they hit the mark. I think that prep and then having a rep come review the first few installs. One thing I would find with these is that you may have somebody who's very familiar with the roofing system, but they may be newer to the PMMAs. They haven't been in the marketplace for the liquid flashings as often for every manufacturer. Some have been around for a lot longer. Have the rep come out, work with the installer, make sure they're familiar. Even if it's an experienced installer, always good for a reminder. And then this is an area where we're really encouraging that apprenticeship program for training, where the newer roofer who's just starting to get used to it is being supervised by a more experienced installer to put it on. So hopefully, Marty, that hits your question.
All right, back to EPDM systems. Barry Meyer, thank you for your question, Barry. He is asking, if you want to minimize weight, what can be used to make the EPDM system walkable that is relatively lightweight?
So this seems like you're looking at putting pavers over top or something over a protection course. So I'm going to take it from that. The EPDM roofing membrane itself is not overly heavy, and the roofing system you would build so it can survive the weight of the deck you're putting it over. If you're looking for something that's lightweight to put on top of it, walkway pads, we can see walkway mats. Those will need to be replaced every once in a while. If we're looking at a paver system, there are a variety of different pavers. Now, if I'm looking for something from an aesthetic standpoint, a lot of the early plaza deck and terrace decks were done with EPDM back in the day. I know I've done plenty of designs on those in the early part of my career. You could have heavier pedestals. Really, to still have that walkable though, you get that wonky thing. That's more a pedestal issue. And so it's looking at that support. And if you want to switch out to something more aesthetically pleasing, like an epay or something that's lightweight, sometimes you got to work with strapping. And I've seen in the last 2 years more interlocking systems where they have a really cool interlocking system to hold that lightweight, what I call roof cladding down. So you can look into those. Many of the designers on the architectural side are now familiar with those and looking at specifying them. And I would say almost every enclosure consultant in the country has been around the block more than once. Not just us as a firm, but there are plenty of other good enclosure consultants, friends in the industry that definitely understand how to do those. Work with them to understand that. And usually for a quick hit, a lot of us will be even willing to pick up a small consulting job just to help you advise on that, a quick repair. You don't have to worry about that. We get that from a lot of our clients. I know all my competitors from all the friends I have in the industry are getting the same questions. I know are willing to take those on. But great question.
Back to EPDM roofs. Mike Henderson, thank you for your question. Mike is asking, is it possible to add a liquid membrane roof over an EPDM roof?
You can add a liquid membrane flashing over it. You can do coatings on these roofs. What I usually look at that is a transition. Maybe you're trying to get a little bit more life out of your roof. These aren't usually permanent solutions. A lot of times as the seams have opened up, they'll continue to move over time and may tear through that even with the reinforcing you may put in. But we do find that you can go over almost any roofing system with one of those liquid coatings or a liquid applied membrane. I think the challenge there is it is really a Band-Aid for a longer term solution. And even if you're going with one of the waterproofing products over top, they will probably tell you the same if you ask the manufacturer. It may buy you 5, 10, 15 years. You could patch it over time to build up enough capital to do that eventual re-roofing product. We definitely have done this on projects where we've helped somebody extend it, but we're very clear up front. This isn't like re-roofing. The other one I get that's similar is the old-fashioned system of over-roofing. Sort of the same thought process, right? If you have a failure in the new roof over top, you can have the same in the liquid flushing or liquid membrane in this case, opening up. It's still going to find that failure that was in the existing product, why you went over it. And now you have a torturous way of trying to figure out where it came in. So that's just something with some of the electronic leak detection, which you can do after the fact, not having the grid that is embedded in the system. You can still help find those leaks. Sometimes with infrared, if it's wet enough, you can help find those leaks. But it is something that is what I call temporary or in between roofing that still has some durability, still very usable in the market, still used by a lot of owners and facilities managers, but I would not see it as a permanent solution.
Right. Let's talk a little bit about green roofs. I know facilities managers are having more and more questions about green roofs as they become more popular. Um, One consideration is watering. How often do you need to water a green roof? And then I think beyond that, are there any particular considerations, maintenance considerations, I suppose, for the actual plantings on a green roof, which is something managers might not be as familiar with?
Yeah, so on the vegetative side, I would say there's two things. You will need to water usually while the sedums are taking, and you'll usually need to water if it gets too dry. If you're in a part of the country where there's fire risk and the plants get too dry, it might be a problem. So some aspect for irrigation. Usually you can work with the landscape architect for your project if you're not working with one. The manufacturer actually has great guidance on what you would need to get the sedums to take or in repair. You will need to maintain plantings. It is plants. So if plants die off, you have to replace them. Otherwise, you're going to end up with a very ugly vegetative roof over time. That's why the tray systems are so attractive to many owners and developers and facilities managers. If you have a bad tray, you can replace it. The other thing to be aware of, in addition to the watering and irrigation requirement, um, is just that you're going to attract wildlife, some wildlife to your roof, which is great. Butterflies, bees, hummingbirds are all fantastic, right? These things that pollinate. Just be aware of where you're putting your rooftop amenity is not where you're likely to have a lot of bees. It may not make your tenants very happy while still surviving both. So sometimes you'll mix the plantings in a way that the plantings nearer where you have that amenity space, maybe on hardscape, are different. So you still have the ability to have pollinators and other things that are wonderful for people to observe up on your roof, but they're away from where they're likely to have a bee sting.
And one additional question about green roofs. Um, how just in general, I suppose, how are the sort of the inspection and testing considerations different for a green roof versus what somebody might, the type of system somebody might be used to maintaining?
So there's additional testing you can put in. You can put in at the waterproofing layer a more permanent grid system, which is electron vector field mapping, electronic leak detection system. What we find with those are very purposeful over critical infrastructure. We want those to usually be tied to an alarm. And there are ways of doing the grid. We've had these on a few projects in the past where you can put each alarm to be independent to a certain sector to kind of help you pinpoint where that is. Then you're able to go up and plug into that system and help pinpoint it more accurately. Um, I think that it's absolutely critical that you can use a lot of these electronic leak detection systems that are becoming newer to the marketplace that don't require the grid system and the permanent, but you're still trying to troubleshoot through a system. The old-fashioned way of still coming up with a hose and a nozzle and soaker hoses to help test and help locate is still important. I would say that you're checking your roof. I would say no less than every 2 years. Every year is still a great idea. Some people, if you have critical infrastructure, it's every 6 months. If you have a major snowstorm or ice hitting the roof, definitely get it up and check after that. And then working through those testing aspects. There's expense up front to buy some of these systems if they're going to be permanent to your system, but the end result is that it should reduce some of your maintenance concerns over time.
And then we have one more question from Ron Orlando asking about an EPDM roof. How often do walk mats on an EPDM system need to be replaced? And how do you know when they need to be replaced?
So the walk mats can need to be replaced when they break down. And I saw Tim's question that was just above that on slipperiness. So yes, some of the earlier mats got quite slippery and the dimples weren't high. And then when it snows and you get ice on the surface, you have the same process. I would ask the manufacturer if they have variations. Sometimes they're not in their standard literature, but they sell them for thicker. And then the other thing is you can put heat trace below those in snow areas to do the melt more efficiently. Yes, there's still some risk, but they can reduce some of that. But that is an ongoing problem with water on the surface. And then on the replacement, I would look at a period of reviewing every 5 years and have some attic stock. If you have an area that's being maintained more often, they may wear down more efficiently in that area. But you should see a 10 to 15-year lifespan on really good walkway pads, and sometimes it's sooner. If they're ones that are heat welded into your system, the one challenge you're going to have on that is you're going to have to come back and probably heat weld new ones over top of them. So sometimes you walk these roofs and I can tell, yeah, they've had walkway replacement. That's been built up a bit and it's been welded over top.
Very good, Paul. Before we conclude the webcast, any last thoughts for our attendees?
So I think it's just a matter of looking at programming this in, really working through all the aspects you want for your roofing system to have success. Really program it in from schedule of when you're replacing or doing new, all the way through maintenance, and then programming out when you're going to reschedule for a future roof replacement. I think planning is going to be absolutely critical. Know that your manufacturer rep can really be an asset that you can use that's out there for you. Ask questions. There's no dumb questions on roofing. There's great questions on roofing. Making sure that what you're looking for. And if you see something while you're walking roof on that new design job, or which is atypical, or on a replacement job, point it out, have it taken care of, and the same on those warranty walkthroughs.
Very good. Thank you to our sponsor, Versico. Thank you to Paul Totten for the excellent insights and information. Watch for your email for in the coming days. The email will contain the CEU test link, the recording, and PDF copy of today's presentation slides. Thanks to all of our attendees. This concludes our webcast.